A leading magazine like Barron's reported at one time that the average number of weeks an individual is unemployed is 16.9 weeks. Assume that for the population of all unemployed individuals, the population mean length of unemployment is 16.9 weeks. So the population mean is 16.9 weeks, and the population standard deviation is 6.3. The standard deviation is 6.3 weeks. Suppose you would like to select a random sample of 246 individuals for a follow-up study. First, we're going to find the probability that a single randomly selected value is between 15.9 and 16.9. And then we're going to find the probability that a sample size of 246 is randomly selected with a mean between 15.9 and 16.9. So let's do the first one first. To find the probability that a single randomly selected value is between 15.9 and 16.9, so to find the randomly selected value x is between 15.9 and 16.9, we're going to find, using our, our bell curve here, we're going to find the probability or the area between the two. I need a different color here. So to find the area between the two, what we could do is find the area to the left of 16.9 and then subtract off the area to the left of 15.9. Fortunately, on our standard normal distribution table, those probabilities are already the areas to the left. So we're going to find the area to the left of 16.9, and we're going to subtract off the area or the probability to the left of 15.9. Now this is an interesting problem because the 16.9 from our sample, our single value sample, is the same. It just happens to be the same as the population mean. Just a little bit different, a little bit strange. Usually, like the 15.9, usually they're different numbers, but this is kind of cool. Since we're dealing with a single randomly selected value, when we find our z values, our critical z values, we're going to use the formula x minus the mean over the population, over the standard deviation of the whole population. So for the first one, let's see, our z value is strange. It's going to be the 16.9 is our random variable minus the population mean, 16.9, over 6.3. But 16.9 minus 16.9 gives us 0. And if you want to look that up on the probability chart, you can for the standard normal distribution, but the probability associated with z equals 0 is right in the middle. It's 0.5. So I'm going to put this in a different color here. Okay, second one. Let's find this. So for this one, again, we're going to do z equals now 15.9 minus 16.9 over the standard deviation, 6.3. So that's going to give us negative 1 over 6.3. I'm plugging that into the calculator. We get negative 0.159. The probability associated with that z-score, negative 0.159 or 0.16, is 0.4364, or at least close to that. So again, I'll put that here, 0.4364. And now when I subtract those two, 0.5 minus 0.4364, I get 0.0636. So the probability that a single randomly selected value is between those two. It's really close to 0.0548, but it should be 0.0636. Okay. The only difference between the first question and the second question is now we're not selecting a single random variable. Now we're selecting a sample size of n equals 246. So everything will stay the same, except when we're calculating our z-values, we're going to divide by the square root of that sample size. So let me erase a good deal of this, but not everything. So erase this up to this. Same exact idea, except I'm going to change this to x bar because this is now our sample mean, and everything else will stay the same. So just like in the last problem, let's see, we have for this z-value, we still have 16.9 minus 16.9 over the standard deviation. And we do technically need to divide by 246, but the 16.9 minus the 16.9 is still going to give us a z-score of 0, which the probability associated with that is 0.5. So putting that up here, we have 0.5. Okay, now for the next one, let's find this. This z-score, 15.9 minus the population mean, 16.9, over 6.3 divided by 246. And plugging all of that into our calculator, I get a new z-value, negative 2.49. I'm looking up on the population, or the probability, standard normal probability chart, the probability associated with negative 2.49 is 0.0064. Or something close. So plugging that up here, 0064, that's an arrow. And then subtracting the two, 0.5 minus 0.0064 is 0.4936. So this probability here will be 0.4936.